All right, so we're starting 6.3, graphing quadratics using the x-intercept. So we're building on what we did yesterday. So how can we use factoring to graph the quadratic relations? So we want to compare the information you can get from quadratic relations from the form y equals ax squared plus bx plus c, y equals ax plus b times cx plus d, and y equals ax minus h all squared plus k. So which is the easiest form to find the vertex, the x-intercepts, and the y-intercepts? So pause for a second and think about what we can find in each form. So this textbook doesn't name them, but we call this one the vertex form because we know that h and k are our vertex. So we have factored form, and now we've noticed, or we've put in, we used to write this differently, but now we've got some coefficients there. We used to write it when we didn't have any coefficients, or sometimes with an a there. So these are two different variations of factored form. And we know when we're trying to find the x-intercepts, we need to solve for ax plus b equals 0. So x equals negative b over a, and same as cx plus a, is that right? D equals 0, so x equals negative d divided by c. So those are our x-intercepts. And our y-intercept comes from our standard form. Y equals ax squared plus bx plus c, where c equals the y-intercept. So even though we can take the same equation and move it around, which is what we're learning now, moving it around into different forms, each form, though the same equation, if we graph them, it would be the same graph, they give us different information. So our vertex form gives us our vertex. Our factored form gives us our x-intercepts, and our standard form gives us our y-intercept. So if we consider the quadratic relation, y equals x minus 2, x plus 4. And that looks surprisingly like minus r. So y equals x minus s, x minus r, which is a formation of our factored form. And we know that in this case, s and r equal our x-intercepts. So we've got to remember that they are negative to start off. So we end up having to change the signs. So our x-intercepts, in this case, are s and r, equal positive 2 and negative 4. So we got to remember there's negatives in there. We could also, if that confuses you, just to switch the sign, then you could go through it the long way and go x minus 2 equals 0. So when we jump over this equal sign, we change our sign, x equals 2. And then x plus 4 equals 0. When our 4 jumps over the equal sign, it changes its sign and becomes negative 4. So remembering that we always need to label our graphs at least 1, 2, 3 in every direction, being down, below, and to the left. And we always want to write the numbers on the lines so that we're not getting confused about which line means what. So we can graph those. Let's use green. So we've got positive 2 and negative 4. So let's just start there. We want to graph, we want to explain how we found our x-intercepts, find and plot the x-intercepts. So I know that if I've got something in the form y equals x minus s, x minus r, that s and r are the x-intercepts, therefore they are positive 2 and negative 4. So how can I find the coordinates of the vertex? So I don't know the vertex yet, and I could do some complicated algebra where I expand out this factored form and then complete the square to get it into vertex form. I could do a lot of complicated algebra that we've already learned, but I'm going to make it easier for myself because I already know the axis of symmetry. And how does the axis of symmetry relate to the vertex? So I know the axis of symmetry is going to be between these 2 points because any 2 points on the graph are symmetrical. So if I know I've gone over 1, 2, 3, 4, 5, 6 points in between them, that the third point in between them is going to be the axis of symmetry. So I know directly between those 2 lines, between negative 4 and, so this is negative 4, 0. This is 2, 0. It should always graph, always put our points on our graph. I know directly in between them is going to be my line of symmetry. So my line of symmetry is y equals negative 1. Now I know that negative 1 is going to be the x-coordinate of our vertex. Oops. So I know negative 1 and y is going to be my vertex. Now I can very simply use that to find my y value. So we don't know what y is. Let's just write down our equation first. We don't know what y equals, but we do know that x equals negative 1. So let's put it in their own brackets. It doesn't really matter in this case, but in some cases it does change things around when we don't have those brackets. If there's a squared, if there's a double negative, it does help. So I always like to start by doing that. So negative 1 minus 1 is negative 3. So remember, we're not multiplying, we are subtracting there. So it's not negative 1 times negative 2. That would look like this. Those are multiplying. We're not doing that right now. We are subtracting. So some people are still mixing up when we're adding and subtracting and when we're multiplying and dividing. So minus 1 plus 4 is 3. So we have y equals, now we're multiplying, because we've got 2 brackets, y equals -9. So I need to add a few more spaces to my graph to get down to -9. So let's plot that again in green. So now we have our vertex of -1, -9. So now we've got 3 points, and we can just draw those in, or we can also look that we don't have an a value in our equation, so we know what the value should be. So we should be able to go over 1, up 1, over 1, up 3, over 1, up 5. Yep, we're correct. And this is also a check to see that we've done it correctly, because it shows us, then we've gone over 1, up 1, over 1, up 3, over 1, up 5, and we've hit our x-intercepts. So that is proven. And we can keep going, over 1, up 2, 4, 6, 7. We can keep going. It proves that we have done this correctly. We know we had an opening up parabola because we have a positive a, even though it's just 1. We know that we're not stretching or compressing the graph at all because there's no a value. A is just 1. There is an a value, but it's just 1. So we know we've got that same pattern of over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. We can draw in our graph from there fairly reasonably. And that's what it looks like in the textbook, but same answer as us. Remember to plot your points. This is what we're forgetting, is putting those actually putting it on the graph, that all of that's there. Do all that. So for each relation, find the vertex, or find the x-intercept, the equation for the axis of symmetry, and the coordinates of the vertex. Use the information to sketch the graph. I'd like you to pause now and do A. Do I have the answers for A? Let's see if I got the answers. Nope. But I want you to try A by yourself, and we can go through that during class. I'm going to do B with you because B is a little bit different, because B has an A coordinate, or an A variable that's not 1. So it looks a little bit different, but not too much. So it doesn't change our x coordinates. It doesn't really do too much for that. So we still, because as we said, if something equals 0, if A and B, A multiplied by B equals 0. Well, now we've just got A times B times C. So we know that either A equals 0, B equals 0, or C equals 0. So right now our A is 2. So basically we've got 0 times 2 times B times C. So 2 doesn't equal 0. So either B equals 0, C equals 0, or both equal 0. Those are our options. So if we're calling this A, everything that's in the brackets here B, everything in the brackets here C, for that analogy. So we know the 2 is just a 2. It's not going to change anything, but we know whatever's in the brackets for B and whatever that's in the brackets for C, either one of those, or at least one of those, needs to be 0. So we can, just as the way we always did, 2x minus 1 can equal 0. We can solve for that. Again, the 1 crosses over the sign. It changes its sign, and then we're multiplying 2 times x, so that makes we divide. So x can equal 1/2. Or 2x plus 3 can equal 0, which means 2x equals -3, or x equals -3 over 2. So we've got two possible answers for x. So we can graph that. I didn't give myself a grid this time, so I'm going to have to draw it. So -1, -2, -3, -4. So always write in your units. We're having problems with that. So we have positive 1/2. So halfway between 0 and 1. And we have -3 over 2, which is -1.5. Halfway between 1 and 2. So we've got our x coordinates in there. And let's, as I've said, we want to always plot them. Oops. And 0 and 1/2 0. All right, so same as before, axis of symmetry. So what is halfway between 1/2 and -1 and 1/2? So this would help to be making half marks. So we've got 1, 2, 3, 4 half marks. So our axis of symmetry halfway through is at 1/2, or -1/2, I mean. So halfway through between. So if we're counting by halves, we got 1, 2, 3, 4 halves in between. So 1 down, 1 full 1 down, or 1 full 1 up is halfway in between. So now we've got an x of our vertex. So as always, the axis of symmetry equals the x on the vertex. So this is something you need to remember. So we know that the vertex is going to equal -1/2 and something. We need to do the math to figure out the rest there. I'm going to erase my thing at the beginning here. So to do that math, we've got 2. So y equals 2 times -1/2 minus 1 times 2 times -1/2 plus 3. So a little bit long, but we need to go through and remember our bedmas. We want to do what's in the brackets first. So inside the internal brackets are just -1/2, so we can't do anything there. So we want to work inside the brackets. So again, if we cross We consider the 2 to be 2 over 1. We can simply multiply them together to get negative 2 over 2, or we can cross cancel like that, so we get negative 1 over 1. Same here. This is 2 over 1, so we could end up with negative 2 over 2, or we can cancel out and have 1 over 1 times negative 1 over 1. Either way, we are ending up with negative 1 minus 1 and negative 1 plus 3. So you can fill in that extra step if you want and have 2, negative 2 over 2 minus 1 and negative 2 over 2 plus 3. So y equals, not a bracket there. Two times, remember we're minusing and adding, we're not multiplying here. So minus 1 is minus 2. Minus 1 plus 3 is 2. So we're going to end up with a negative number because we've got 1 negative and 2 positives. And 2 times 2 times 2 is 8. So our vertex equals negative 1/2, negative 8. So negative 5, negative 6, negative 7, negative 8. Unfortunately, we're really close there. So negative 1/2, negative 8. And now we've got enough to draw us in. So we're going to have a very thin, wide vertex or parabola there. Okay, so but it was the same steps. So we still need to plot our 3 points. We found our x-intercepts, the equation of the axis of symmetry by finding what's in between those two, and the coordinates of the vertex by using the axis of symmetry as our x, and then solving for our y. One more. All right, so our official examples. Again, we're going to do the same thing over and over and over again. Find the x-intercepts, the coordinate of the vertex, then sketch each parabola. So we need to find x-intercepts, axis of symmetry, coordinate of the vertex. But this time, they're not giving it to us in factored form. They're giving it to us in standard form. So we need to go through the steps we already know from previous chapters to be able to do that. So I want everybody to look at page 263 to make a copy of that chart, to look at the different ways that we can factor our quadratic relations and figure out which one is which. So this one is a y equals x squared plus bx plus c. There's no a term. So all we have to do is find two numbers. We want to find an r and an s that multiply to c and an R and an S that add to B. So our factors of 7, and 7 only has 2 factors. You can be 1 and you can be 7, or you can be -1 and -7. But since our B is positive, we know our numbers are 1 and 7. So we can just jump straight from this guy to our factored form, because we do not have an A value greater than or less than 1. We just have 1. So we end up with, because 1 and 7 multiply to C, 1 times 7 is 7, and they add to B, 1 plus 7 is 8. We can just put them straight into that form. So then we know our R and our S, our x-intercepts, are just the opposite signs, and you can figure that out if you want them to be equal to 0, are -1 and -7. So again, we need to plot all of this. 4, 5, 6, 7. 1, 2, 3, -2, -1, -3, 1, 2, 3. So at least give me that so I know what you're using. Let's use a different color. So now I've got -1, 0, -7, 0 as my 2 points. Again, find what's in the middle. Our axis of symmetry is always in the middle. That's the definition of an axis of symmetry. So if I've got -7 and -1, 1, 2, 3, 4, 5, 6, there's 6 in the middle. 1, 2, 3. So -4 is directly in the middle. For axis of symmetry is x equals -4. Sometimes it may end up being a fraction, a half, but right now we've got a whole number. So easy enough to then put into our, and let's go back up to the original formula, original equation. So make sure we didn't make any mistakes. So it was a little easier that way. So we want to put in -4 for x. So again, this is where the brackets become important, because we have brackets around the -4, it becomes +16. So it's not -4 squared, it's the square root of -4. Minus 32. So if we add the 2 of them together, y equals -9. So now we've got the axis, we've got our vertex going on. So we know we've got -4. I need to add some more. So I know where -9 is. And again, right in our points. So -4, -9 is our vertex. And then we've got our 3 points. Again, because we don't have an A, we know we go over 1, up 1, over another 3, up, or over 1, up another 3, over 1, up another 5. So we can put in the points in between rather easily. And keep going up. Put the arrows at the top of your lines, showing that that vertex continues to go forever and ever. All right, B. So B, we do have an A term, which means that we need to find two numbers that multiply to now A times C, which equals 2 times -6, so -12. And they also need to add to our B term, which is -1. So we need to find the factors of -12. So we can have -112 or -12(1), -2 6 or -6 2, or -3 4 or -4 3. So since we want -1, when we add up all of those, we are nowhere near, +1, -1. So we know that's where we want to be. So now we've got to use the strategy of grouping. So we need to divide out, pull apart that B term. And again, put the positive term second. It makes the grouping a lot easier. If obviously this one, 2 and 4 and 3 and 6 kind of go together, but always put that negative term first if you've got a choice, because it makes the math a lot easier. So then what can we pull out of our first two groups? We can pull out a 2x, leaving us with an x minus 2. We can pull out a +3, leaving us with an x minus 2. Now, think of what's inside the brackets as a pumpkin. You've got 2x pumpkins, I've got 3 pumpkins. Together, we leave our pumpkins alone, we don't change them. Together, we have 2x plus 3 pumpkins. So that doesn't change. We just group together what's inside the brackets and then everything else that is left. So now we can find our x coordinates, and we're going to end up with a fraction, because we know that either the first section has to be 0 or the second section has to be 0. So x minus 2 can equal 0, and x can equal +2, or x2 plus 3, 2x plus 3 can equal 0. 2x can mean us -3, so -3/2. There's my math book. 1, 2, 3, -1, -2, -3, -1, -2, -3, 1, 2, 3. So we have +2, and we have -1.5. So here is where our axis of symmetry can get a little bit trickier. So finding the x coordinate of the vertex is going to be a little bit trickier. So there is actually a formula that we can follow. And if we do one of the x's, our x term plus our other x term, all divided by 2, we can find that. So I've always done it kind of breaking it up. So if we broke them up by halves, but we're going to end up with a quarter this time, so it's a little harder to judge how much in the middle there are. So if we go -3/2 plus 2 divided by 2, we end up with 1/2 divided by 2, which equals 1/2 times 1/2, because we would inverse and multiply, remembering our thing. So if this is 2/1, so basically that's what we're saying. 1/2 divided by 2/1, we inverse and multiply. So we switch the second term to 1/2 instead of 2/1, and we're multiplying, which gives us 1/4. So our x coordination, or x term, is actually positive 1/4, which is really hard to draw on my little graph. So right about there. So even if we call this x1 plus x2, so our two possible x's, x1, x2, our two possible x's, add them together, divide by 2, and we're going to find the x coordinate of our vertex. So now we need to find, and I'm completely out of space, we need to find our y coordinate of our vertex. So if you want to keep this, give it a screenshot now, because I'm going to erase. So now we have 1/4. We'll go back to our original equation. Y equals 2 1/4 squared minus 1/4 minus 6. So remember, we're squaring the top and squaring the bottom. So 1 squared is 1, 4 squared is 16, minus 1/4 minus 6. Again, we can cross cancel out and make this an 8, make this a 1. So we divided them both by 2. 2 divided by 2 is 1. 16 divided by 2 is 8. Y equals 1/8 minus 1/4 minus 6. Now we need to find a common denominator, and that would be 8. So y equals 1/8. In order to get 1/4 to have a common denominator of 8, we need to times by 2. In order for 6 to have a common, so 6 is technically over 1, so we need to times by 8. So we end up with, so this is fraction work. If you don't get fraction work, you're going to have to go back to find some worksheets from the beginning of this class, from the beginning of grade 7. Find something, work on that if we don't understand what I'm doing right here, because fraction work is below this grade level. You need to work on it. So then we are just adding and subtracting our numerators, because everything is over 8. And we end up with negative 49 over 8. So they did give you a very complicated one. And negative 49 over 8 is just below negative 6. So if we did that division, 48 divided by 8 is 6. So we're just below negative 6. So negative 4, negative 5, negative 6. So our vertex here is going to be just below it. So we've got 1/4 and negative 49 over 8. So a little complicated in our there, but we should be able to work with fractions. And that is B. Okay, so we're going to pick up the next video starting with our C and moving on to example 2 and example 3. But that is what we're going to do today. Please look at the overall homework and figure out which ones you can do based on what you've seen so far.